The eighth question that we have is a very interesting and a very important question. We have a string fixed at both ends. It vibrates in lowest mode of vibration, for which a point P at L by 4 distance from one end is a point of maximum displacement, that is it is an antinode. Now frequency in this mode is equal to 100 Hz. What we need to find out is the frequency emitted when it vibrates in next mode such that the point P again has maximum displacement. We just need to find out the next mode, immediate mode. Now for solving this question, we have to analyze the first part first. It vibrates in the first, we need to find out the lowest mode of vibration. Which is that lowest mode of vibration? So let us find out. Let us draw the diagram of the string. It is always very helpful to draw the diagram of the string. This is the string fixed at both ends. The total length is L. Now there is a point P at L by 4 distance which has maximum displacement, that is it is an antinode. Now we need the lowest mode of vibration. So we know that for a string the different frequencies are Nv upon 2L. This is applicable for string fixed at both ends. The various frequencies in which it can vibrate are Nv upon 2L, where n takes the values of integers, or rather it takes the value of 1, 2, 3 and so on. We need that it should be the lowest mode of vibration. Lowest mode of vibration means the minimum number of loops, that is the minimum frequency. For that, this should be the first antinode. Therefore this is the first antinode. The distance of antinode from the first node, that is this point, is lambda by 4. Therefore lambda by 4 is equal to L by 4, that is lambda is equal to L. Therefore it is vibrating in this fashion. Therefore the number of loops is 2. Here n is also the number of loops. Therefore it is vibrating in 2 loops. Therefore the frequency is equal to 2V upon 2L, that is equal to V upon L, and the value of V upon L is given to be 100. Therefore what we remember is that V upon L is equal to 100. What you needed to realize was that for a lowest mode of vibration, the frequency had to be lowest. For the frequency to be lowest, the number of loops had to be lowest, and for the number of loops to be lowest, this should have been the first antinode. If this wouldn't have been the first antinode, there would have been more loops here, and the number of loops would have increased and the frequency would have increased, and that would not have been the lowest mode of vibration. So for lowest mode of vibration, number of loops comes out to be equal to 2, and that gives us V upon L is equal to 100 Hz. Now for the second part, we will use this information. We need to find out the frequency emitted when it vibrates in the next mode such that the point P again has maximum displacement. So the point P, for point P to have maximum displacement again, it again has to be an antinode, and since it has to be just the next node, therefore this has to be the second antinode now. Now we have to make this the second antinode. This was our point P. Now this will become the second antinode, because if it becomes a third antinode, it will have the total system will have more number of loops than the case in which this was the second antinode, and we want just the next mode, such therefore it has to be the second antinode. Now for a string, this is the first antinode and this is the second antinode. Let this be any string. Now the distance of the second antinode from here is, this is lambda by 2, this is lambda by 4. Therefore the distance of second antinode from this end point is lambda by 2 plus lambda by 4, that is equal to 3 lambda by 4. Therefore we now know that for the second case, 3 lambda by 4 is equal to L by 4, because we know that the second antinode is at a distance of L by 4 from this end point. Therefore lambda is equal to L upon 3. We know that lambda f is equal to V. Therefore frequency is equal to V upon lambda, that is V upon L into 3. Now we know the value of V upon L as 100. Therefore the frequency comes out to be equal to V upon L into 3, that is equal to 300 Hz. So final answer for the frequency emitted when it vibrates in the next mode such that point P again has maximum displacement, or rather it is again the antinode, comes out to be equal to 300 Hertz. So for solving this question, you just had to draw the diagrams properly and analyze them conceptually and slowly.